Good day, students. So, we are starting with a new topic of maths. The first chapter of maths is real numbers. I not like to go with the exercise like exercise 1.1, 1.12, not like to go with that because I am not very happy with the way the exercises are arranged. The syllabus is not that much linearly going, so I like to go in my own way. See, first I like to see that they are trying to teach you HCF and LCM of numbers. You must be knowing what are HCF and LCM of the numbers. HCF stands for highest common factor, whereas LCM stands for least common multiple. I'll come back to the basics of these names afterwards, that there is some confusion some students really follow regarding the name highest common factor and the least common multiple. I'll come back to that afterwards. I like to go to the basics of this. Of course, to find the HCF and LCM of any two numbers or more than two numbers, we have to first know that by the basic arithmetic mean, by the basic arithmetic method of finding the HCF and LCM, we have to first know to find the factors of the numbers. So supposing if we have been given a number like supposing 420, and we have to find the factors of 420, then what do we do? Finding prime factors. Of course, we have to take prime factors of 420. Now, prime factors, I think you should be knowing what are prime factors. Prime factors are the numbers that are 2, 3, 5, 7, 11, 13, 17, 19, and so on. Basically, they are the numbers who are divisible by only themselves. No other number can divide them. Or we can say that they come in the table of themselves only. 2 ones are 2, and then 2 will not come in any other table. So they are divisible by themselves and no other number can divide them. And of course, one thing more you have to remember, that 2 is the only prime number, even number, which is prime number. 2 is the only even prime number. Rest all numbers are odd numbers. Of course, basically the reason is that any other even number is going to be divisible by 2. So because any other even number is divisible by 2, the other numbers cannot be prime factors or prime numbers. So finding the prime factors of 420. So if I go to find this is now something different. So I square this separate. So how to find the prime factors? We can go into the rough like that. 420. If I find the prime factor of 420, 2 2s are 4, 2 1s are 2, 2 zeros are 0. Then again I divide this. Here you have to be very careful. 2 1s are 2. Now we are supposed to take only 1. You are supposed to take only 1. 2 1s are 2, 0 is remaining. So if you visualize, there is only 0 over here, and then you borrow another digit 1. So it is 1 only over here. So it becomes 2 zeros are 0, zeros are 0, and then you have to come over here, 2 5s are 10. This division is very, very, very important. Many students, when you divide in this fashion, they get confused over here. So I'll rather make it, show it in a normal way. 210. When we divide this 210 by 2, so what we do, first we divide only 2 1s are 2. We divide only 2 1s are 2. We divide only one number, 2 1s are 2. See, I'll divide only this first digit because it is divisible. 2 1s are 2, 2 1s are 2, and then there is a 0 remaining over here. As I told you over here, there is a 0 remainder over here, and then I will borrow only one next digit down. So what I have got is 0, 1, 0, 1, and 0, 1 is divisible, 2 zeros are 0, and then 1 comes down, and then this 0 comes down, and then it becomes 2 5s are 10. So same thing we are going to do over here. 2 1s are 2. There is a 0 over there. So 0 you have to imagine over here, and then only 1 comes over here. So basically you are going to divide 1. So 2 zeros are 0 is only thing possible over there, because that is only the number which will be divisible over there. 2 zeros are 0, and then only 1 remains, and then you have 10. Then you can borrow another digit. 2 5s are 10. I hope this is clear with you all people, and this is really very important. Now this number cannot be divisible by 2. So the next number is what? 3. Is this divisible by 3? Yes, if I add all the digits, 1 plus 0 1, 1 plus 5 6. So this is divisible by 3. So 3 3s are 9. Now again 1 remains. 3 5s are 15. So now is this divisible by 3? 5 plus 3 8. No, so this will not be divisible by 3. I'll have to go further. So 2 is over, 3 is over. The next prime number is 5. So I write over here 5. 7s are 35, and now only 7 stays. So 7 1s are 7. So these are all the prime factors of 420. So what I'll write over here, 420 is equal to 2 into 2 into 3 into 5 into 7. 2 into 2 into 3 into 5 into 7. This is how you will be finding the prime factors. But if you write them into the power form, so 420 is equal to, now there are 2 2's, so I'll write 2 raised to the power of 2 into 3 into 5 into 7. Why do you have to write them in the power form? That is also important, because afterwards you will be requiring that. So that is how you will find the prime factors. I'll take one more example for you all people to understand in a better fashion. So supposing I take another number 27300. You all can take a try over there. If you want, you can pause this video, pause it, and then find the factors of it, and then afterwards you can resume the video. So 2730, again I'll do the same thing. I'll try to first factorize them. 27300. Now this is 0 at the end, so it will be divisible by 2. 2 1s are 2, 2 3s are 6, 1 stays. Visualize over here, imagine over here 1 and 3 13. So 2 6s are 12, 1 is the remainder again. Visualize, imagine 1 over here. This is 10, 2 5s are 10, and then again 0. So again this will be divisible by 2. You have to imagine these two numbers. 2 6s are 12, 1 stays, 2 8s are 16. So here everything is gone. Now only 5, 2 2s are 4, and then 1 stays, 2 5s are 10. Okay, so now the next is this divisible by 3? You have to add all this. 6 plus 8, 14, 15, 16, 17, 18, 19, 20, 21. So this, if I add all of these digits, the sum is 21. 21 is divisible by 3. Yes, 3 7s are 21. So definitely this also will be divisible by 3. So I go for the division. 3 2s are 6, 8 remains, 3 2s are 6, 2 remains, 3 7s are 21, 1 remains, 3 5s are 15. I hope you all understand this. If you really don't understand this, then you can let me know, and then I'll try to explain you this division in the better way. I can develop a video for that separately, but I hope that you understand this. So now if I add these all, 2 plus 2 4, 4 plus 7 11, 11 plus 5 16. So now this will not be divisible by 3, because the sum of all these numbers, these digits, is 16, which is not divisible by 3. So now what? I'll go for 5. To identify whether the number is divisible by 5 or not, what you have to do is just see the digit in the units place. If the digit in the units place is 0 or 5, then definitely this will be divisible by 5. And here also, because the digit in the units place is 5, so this will be divisible by 5. So I'll write over here 5 4s are 20. So 22 was the number, 5 4s are 20. 22 minus 22 remains. So I imagine 2 over here, and then 7 comes. This is 27. So 5 5s are 25. 27 minus 25 will give me 2. So this will be 25 over here. 5 5s are 25. So again this is divisible by 5. 5 9s are 45. 5 1s are 5. Now this is not divisible by 5. Now 91 will not be divisible by 5 any further. Now from henceforth you will have to just know the tables and everything. 7, yes, 13 7s are 91. So this will be divisible by 7 1s are 7, 7 3s are, and then this will be 13 1s are. So like this you will be able to factorize them, and then now these are the factors. 27300 factors are 2 into 2 into 3 into 5 into 5 into 7 into 13. These are the factors, and of course if I go to write them into the power form, I will have to write like this: 2 raised to the power of 2 into 3 into 5 raised to the power of 2 into 7 into 13. So here, students, we have actually climbed one step, finding the prime factors of the numbers. Remember, but this is too basic. We don't get any questions based on this topic. Of course, but the next topic as we go further, finding the HCF and LCM. Now you will come to know why I have found the factors, and not only found the factors, and why I am writing them in the exponent form. See, my dear students, I'll go to the basic numbers first, small numbers. These numbers are too big to start with. I'll like to go to the basic numbers. Which one do I take? Okay, I'll take numbers. So I'll take the numbers 12 and 72. See, if I find the HCF and LCM of 12 and 72. Of course, when you are going to find the HCF or LCM, HCF and LCM are always between 2 or more numbers. I'll explain you properly what is HCF and what is LCM. You must be knowing that, but still there is some confusion. Some students carry between them. I'll try to clear them as much as possible from my side. And if you all don't have any confusion, then it's well and good. So coming back to the topic here, HCF and LCM, if I have to find the HCF and LCM of 12 and 72, so first I will have to find the prime factors of them. So it's not necessary that every time we have to factorize them. So here we can make out that it is 2 into 2 into 3. But if it is, for clarification's sake, I can still go 12. First I will divide this by 2. 6 are 12. 2. 3s are 6 and 3 1s are 3. So in this way I get 2 into 2 into 3. So this is 2 into 2 into 3. Now if I go to write it in the exponent form, it will be 2 raised to the power of 2 into 3. This is 12. Similarly, I will go for 72. For 72, if I go 2, 3s are 6, 2, 6 are 12, 2, 1s are 2, 2, 18s are 36, 2, 9s are 18, 3, 3s are 9, 3, 1s are 3. So here if you'll see, it is 2 raised to the power of 3 and 3 raised to the power of 2. So it will be 2 into 2 into 2 into 3 into 3. So 72 is equal to 2 cube into 3 square. So in this way we have got the factors of both the numbers 12 and 72. Now what next? See here, my dear students, HCF and LCM. We have to know that HCF is equal to, see, when we are going to find the HCF of 12 and 72, we have to notice two things. First is common factors. Common factors are the factors which are present in 12 also and 72 also. In this case, 2 is present in 12 and 2 is also present in 72. So 2 is a common factor of 12 and 72 because it is present in 12 also, it is present in 72 also. At the same time, 3 also is a factor of 12 and 72. So first of all, we have to consider only common factors when it comes to HCF. HCF, only common factors play a role over here. And in that, the next topic is the powers of the common factors. HCF is a product of smallest power of common factors. So remember this. First of all, they have to be common factors. You can't take any number. We'll come to the more example. We'll come to more examples afterwards. So you can't consider those numbers which are not the common factors. It will happen many a number of times that there are some factors which are present in one number and they are not present in the other number. So you are not supposed to consider them. You have to only consider common factors and the smallest power of the common factors. So in this case, HCF, of course, the common factor 2 is also the common factor and 3 is also the common factor. Now, what is the smallest power of common factor 2? The smallest power is 2. So I'll write 2 square into what is the smallest power of 3? Common factor 3, the smallest power is 1. So I'll take only 1. So HCF is equal to 2 2s are 4 into 3, that is equal to 12. So I write it like this: HCF of 12 comma 72 is equal to 12. So this is important. See here, this, my dear students, this you may not need to write in the exam, but I like to see that when you solve my assignments and my question papers, I will need this, and for this I will be giving you half marks, or if you don't write this, I will be cutting you half marks. Definitely when your school exams are there or board exams are there, you may not need to write this. So basically HCF is what? HCF is a product of smallest power of common factors. You have to consider two things: common factors and then smallest power of those common factors. And same when I go for LCM. LCM is what? LCM is product of highest power of each factor. Remember here, every factor you have to take, each and every factor, whoever is appearing over there, and that too each factor highest power you have to consider. So let us come over here. LCM in the above example, LCM of 12 and 72. LCM of 12 and 72 will be equal to what? Now if I go to consider the each and every factor I have to take, 2, 3 are the only factors over here, 2. Now here what is the highest power of 2? 3. So I will have to take 2 raised to the power of 3 into 3. Highest power of 3 is 2. So this will become 2 to the 4 to the 8, 3 3s are 9, and then the least common multiple is 72. So my dear students, you will see over here HCF of 1272 is equal to 12. LCM of 1272 is equal to 72. So this is one step that we have gone forward, how to find the HCF and LCM of two numbers or more numbers also. But I'll come back to the basics that I have told you before, that I'll try to explain you, because some students have a confusion regarding over here in the names, as I told. See, in this case we will take the example that we have got HCF of 1272 is equal to 12 and LCM of the same numbers 1272 is equal to 72. See, the name is what? Highest common factor, and the highest common factor is 12. Least common multiple, and it is 72. So sometimes students get confused that the name is highest and still it is lower than the LCM least. How is that? If others don't have any confusion regarding this in this line, if they know why it is, it's okay, it's good. But for those who have some confusion regarding this, see my dear students, first of all, instead of stressing more attention on highest and least, this is important my dear students to understand. Instead of stressing more attention on highest and least, stress more attention on factor and multiple. Factor and multiple. Highest common factor. What is a factor? Factor is a number which can divide any number. Like example, we have got over here 12. So 12, the factors of 12 are what? 2 and 3. That means 2 can completely divide 12. 3 can completely divide 12. So 2 is a factor of 12. 3 is a factor of 12. You can write it in this fashion, that 12 divided by 2 is equal to 6. Okay, fine. This will be slightly confusing. Fine. I'll come back to this. But see, 2 is a factor of 12. 3 is a factor of 12. Okay, I'll come back here. 2 divided by 2 is 6. You will get over here. And also 12 divided by 3, you will get 4 over here. So like this, 2 is a number which is divisible, which is dividing 12. 3 is a number which is dividing 12. Similarly, for 72 also, 2 divides 72 also, and 2 divides, and 3 divides, 3 also divides 72. But if I go further, if I go further, so I have got numbers 6. 6 will also divide 12, and 6 will also divide 72. There are many numbers like this. 12, 6 will divide 12, 6 2s are 12, and it will also divide this. Will divide 72 also. Are you getting? Like this, if you'll go on, but if you'll notice, now 7 is not a factor of them, 8 is not a factor of them, 9 is not a factor of them, 10 is not a factor of them. But if you'll come to 12, 12 is divisible by 12, and 12 is also dividing 72. So if you'll find 12 is the highest number, highest common factor. It is the highest common factor which will completely divide 12 also and will completely divide 72 also. So that's why highest common factor. Factor means you have to search for the numbers who can completely divide both the numbers, or all the 3 numbers, or all the 4 numbers. They completely divide all the 2 numbers or all the 3 numbers that are given to you. LCM is exactly opposite of this. Common multiple, they are going to come into the table of 12. Like In the table of 12, we have got 12 ones are 12, 12 twos are 12, 12 twos are 24, 12 threes are 36, 48. It goes on. Similarly, 72 also. You have got 72 ones are 72, and it will go on 72 twos are something and all. But somewhere they will go on, both the multiples will reach each other and they will reach to a same multiple. Like this, you will have only 72 is the least number. 72 ones are 72. At the same time, 12 6 are 72. So 72 is the number where both will multiply and have a common multiple. So common multiple is the number where both the numbers will multiply with some number and reach to that one number. So 72 is that number where both of them will multiply with some other numbers. The table of 12 will be written, table of 72 will be written, and one multiple will be there which will be coming first time in the table of both. So here this is the case. Likewise, that's the reason it is because of factor, it is going to divide both the number. So because this factor is going to divide both the number, it has to be either lesser than both the number or equal to the lowest number. LCM, because it is going to multiply, so it can be greater than the greater number or it will be equal to the greater number, like it is happening over here. One more thing, very important tip that you have to remember is that among the two numbers, whose HCF or LCM is to be found, remember students, if the smaller number is completely dividing the greater number, there are two numbers, this is a number A, there is a number B. If B is greater and A is smaller, if smaller number is completely dividing the greater number, then if A is a factor of B, means A is completely dividing B, then HCF of A and B is the smaller number and LCM of A and B is the greater number. So this is exactly what is happening over here. The smaller number is completely dividing the greater number. So the HCF of 12 and 72 is 12. And the LCM of 12 and 72 is 72. So this is one topic. We have first understood how to find the factors of the given numbers, and then we have understood how to find the HCF and LCM by the basic arithmetic method. We can take few more examples of this and then we can go to the next step. Few more examples I'd like to take of these numbers. Now what we can do is that we can go for more number of numbers. Like supposing we have to find HCF, the pen is over. Find HCF and LCM of 24, 60, 150. There are now three numbers, 24, 60, 150. If I have to find the HCF and LCM of all these three numbers, so definitely first I will have to factorize them. 24, the factors of 24 are what? 24, 2, 12 are 24, 2, 6 are 12, 2, 3 are 6, 3, 1 are 3. So we can very easily write it directly in the exponent form. 2 into 2 into 2. Sorry, I did not write in the exponent form because somehow I'm not comfortable with that. 2 cube into 3. But if you are comfortable, you can write directly the exponent form. Somehow I am not. So 60 is equal to what? So I have to find the I have to factorize 60. So 2 30s are 60, 2 15s are 30. Now 3 5s are 15, 5 1s are 5. So 2 into 2 into 3 into 5. So I'll get what? 60 is equal to 2 into 2 into 3 into 5. So 60 is equal to 2 square into 3 into 5. Sorry. Going to 150. 150, if I'll factorize this, 75s are. Now this will be divided by 3, 12. 7 plus 5 is 12, so 12 is divisible by 3, then definitely 3 will be dividing 75 also. 3 2s are 6, 3 5s are 15. Now this will be not divisible by 3, 5 5s are 25, 5 1s are 5. So I get 2 into 3 into 5 into 5. Okay, so 2 into 2 into 3, 2 into 3 into 5 into 5. So this will become what? 150 is equal to 2 into 3 into 5 square. So this is how. Now HCF is what? HCF is product of smallest powers of each common factor, right? So here HCF of 24, 60, 150 will be equal to what? Common factors are what now? 2 is a common factor over here and 3 also is a common factor. You can see 2, 2, 2, 3, 3, 3, but 5 is not a common factor. So 2, 2, 2, the smallest power of 2 is 1 and smallest power of 3 is 1. So HCF is going to be 2 3s are 6. So if you counter check, 6 will divide 24. Yes, 6 4s are 24, 6 10s are 60, and this also will be 6 2s are 12, 6 5s are 25s are 150. Okay, you will not be able to find a number which is higher than 6 and will be dividing all the 3 of them. No, you will not find any number which will be higher than 6 and will be dividing all the 3 numbers at a time. So that is what this I want you all people to write in my assignments, in my class tests, in my exams that I conduct in our classes. Remember, this will give you half marks or this will cut you half marks. In your school exams, you are free not to write them. It's okay. Now LCM, if I find, LCM is what? LCM is product of highest power or greatest power of each factor. Remember this, of each factor. Of each factor. So here LCM of 24, 60, 150 will be what? See now, first 2 is present everywhere. So highest power of 2 is 3. So it will be 2 cube. 3 is present everywhere and the highest power is also 1. 5 is present everywhere and the highest power of 5 is 2. So I'll get it as 5 square. So this will become 2 to the 4 to the 8 into 3 into 5 5s are 25. So we can multiply this first. 25 3 is 75. 75 into 8. 8 5s are 40. 8 7s are 56 plus 4 60. So that is equal to 600. So we can get that LCM of 24, 60, 150 is equal to 600. So we have got both HCF and LCM, and this is how we are going to find the HCF and LCMs of the numbers, whether there are 2 numbers or there are 3 numbers. I'd like to take one more example of 2 numbers only, because that will take us to the next topic then afterwards. Next step, not topic exactly. When I find one number. Okay, we've got one. Find the HCF and LCM of 404 and 96. Find HCF and LCM of 404 and 96. Okay, my dear students, you can pause this video over here. Pause it, try to solve it on your own, and when you solve this, you can run through the video. You can increase the speed of the video and then cross check your answer, but I'll try to solve it according to my way. So if we have to solve this 404 and 96, so of course we'll have to first factorize them. 404, if I go to factorize, what I'll get is 2 2s are 4, 2 2s are 4, then again 2 1s are 2, 0 1s are 2. Okay, fine. And then you will find that this 101 is a prime number in its own. You will not find the factor of 101. So this will become 2 into 2 into 101. I'll let you know how to identify that it is a prime number or not. Sorry. So this will become 404 is equal to 2 square into 101. We have a question separately on this. How do you identify a given number is a prime number? Higher numbers are prime numbers. I'll go to that topic afterwards. 96, 2 4s are 8, 8s are 16, 2 24s are 2, 12s are 2, 6s are 2, 3s are 3, 1s are. So what I get over here is 96 is equal to 2 into 2 into 2 into 2 into 2 into 3. So 96 is equal to 2 raised to the power of 5 into 3. So this is what is factorization done of 404 and 96. And now we have to find the HCF. HCF is product of smallest powers of each common factor. Of each common factor. Here we will get what? The HCF of 404 and 96. Common factors are what? Only 2 is a common factor. 101 is a factor over here but not over here. 3 is a factor over here but not over here. So common factors are only 2. Common factor is only 2. So this is going to be 2 and the smallest power is 2. So there is going to be 4. So HCF of 404 and 96 is equal to 4. And now going for the LCM. LCM is product of highest or greatest power of every or each factor or every factor, whatever you take. Every factor I have to consider. So here LCM of 404 and 96 is equal to what? So every factor, the 2 is a factor over here and the highest power is 5. 2 raised to the power of 5 into, the next is 3, highest power is only 3 into 101. So if I go to find this, what I'll get is 2 2s are 4, 2s are 8, 2s are 16, 2s are 32, 2 2s are 4, 2s are 8, 2s are 16, 2s are 32 into 3 into 101. This will give me 6, 3 3s are 96 into 101. This will give me 101 into 96, 6 1s are 6, 6 0s are 6, 6 1s are 9 ones are 9, 9 zeros are 0, 9 ones are 9. This gives me 9, 6, 9, 6. So 9, 6, 9, 6. LCM of 404 and 96 is this. Yes, my dear students, so this is how we will be finding HCF of numbers and LCM of given numbers. Now we can go to the next topic of this topic. We have found the HCF of two numbers, LCM of two numbers. Now what next is that? See, when we find HCF and LCM of two numbers, then we find the HCF and LCM of two numbers. One thing is there, but if supposing we have to know one more topic. See, my dear students, if there are two numbers, see, A and B are the two numbers. HCF of A and B and LCM of A and B. If I multiply this, HCF of A and B, if I know the HCF of A and B, if I know the LCM of A and B, if I multiply this, it will be equal to the numbers, product of the numbers themselves. If I multiply the HCF of two numbers with the LCM of two numbers and multiply the numbers themselves, you will get the same values. This is one property that you have to remember. Why you require this? Because questions based on these topics may come. Like example, sometimes they will ask you to prove also this thing. So if you will see over here the same number, if supposing find HCF and LCM of 404 and 96. This will be there, and prove HCF into LCM is equal to product of two numbers. They can ask a question based on this, that first of all find the HCF and LCM of two numbers and then prove that the product of the HCF and LCM is equal to the product of the two numbers. So in this case we have found the HCF, we have seen this, HCF of this is 4, LCM of this is 9696. So now if I have to prove that, now verification of the property HCF into LCM is equal to product of the two numbers. That's what you are going to do over here. So what we do, the numbers are what? 404 into 96. You will have to do this first. We have found the LCM and HCF of 404 and 96. Sorry. So I have to first multiply 404 and 96. So what I will get is 404 into 96. 6 4s are 24, 6 4s are 24. 9 4s are 36, 9 4s are 36. 4, 8, 7, 8, 3. So you get this as 3, 8, 7, 8, 4. Okay, so this is what you will be getting, and then what I have to do is, this is, you can label as 1. That's next time what I will do, multiply HCF and LCM of 404 and 96 multiplied by LCM of 404 and 96. Sorry, this will give me what I had got. I had got 404 HCF was 4, HCF is 4 and LCM is 9696. So it will be 4 into 9696. So here 4 6 are 24, 4 9 are 36, 37, 38, 4 6 are 24, 27, 3 8 7 8 4. What we got over there. 38784. So this is equal to 2. So from 1 and 2 we get what? That 404 into 96 is equal to HCF of 404 96 into LCM of 404 96. Fine. That's all. Understood? So that's what we have covered till now, and we are covering. First we understood how to find the HCF and how to find the LCM. I repeat, first, for finding the HCF and LCM, you should know how to factorize the given numbers. So this is one technique that I have showed, how to factorize the given numbers. First factorize the given numbers and then write the numbers in power form, exponent forms. Once you write both the numbers in exponent form, then you should know the property of this, how to find the HCF. HCF is the product of smallest powers of each common factor, and LCM is product of highest power of each factor. This is very important. HCF involves only common factors and smallest power of common factors. LCM involves each factor and greatest power of each factor. So multiply the both and you will get HCF, you will get LCM. Here one topic gets over, and then next is what they will usually ask you to prove that HCF into LCM is equal to the product of the two numbers. All product of two numbers is equal to the HCF of the two numbers multiplied by the LCM of the two numbers. So you will go to this and then you will find what you will do is that first you will multiply the two numbers 404 into 96, whichever the number they have given you. First multiply the numbers themselves and write down those numbers. 38784 is 1, and then you multiply the HCF and LCM of the two numbers, and both the numbers should come same. Now what next? Next is what we will do, that we will do it the same exercise we will do with this. We had found the HCF and LCM of 24, 60, 150. This we had done just now. We found the HCF in the same fashion. What we did, we factorized the 24, wrote the factors in the exponent form, power form. We factorized 60, wrote the exponents of 60 in the power form. We factorized 150 and wrote the exponents in the power form. Once we have done this, then we find the HCF by the same method, that HCF is the product of the smallest powers of each common factor. LCM is the product of the highest power of each common factor, and we found the HCF and LCM. Now what? I guess you will be guessing what is the next is what? Is 24 into 60 into 150 equal to HCF of 24, 60, 150, 6, and into LCM of 24, 60, 150. See here, we will go back, I will solve this. Here if I multiply this, 24 into 60 into 150, what I get is 24 into 60, 0, 6, 4 the 24, 6, 12, 13, 14, 1440 into 150. So I'll have to multiply them, 1440 into 150. So this is 0, 5 0 are 0, 5 4 are 20, 5 4 are 20, 21, 22, 5 5, 6, 7. Then I go to the next step. This is 0, 4, 4, 1. This will give me 0, 0, 0, 6, 11, 216, 000. That is equal to 216, 000. This is your first point. 24 into 60 into 150 is equal to 216, 000. Now what? Next is HCF of 24, 60, 150 into LCM of 24, 60, 150 is equal to what is the HCF? 6. What is the LCM? 600. This is going to be 3600 only. Consider this, please. This is 2, and from 1 and 2 what you get? From 1 and 2 we get, sorry, 24, 60, 120, no? 24, 60, 150. 24 into 60 into 150, HCF of 24, 60, 150 into LCM of 24, 60, 150 are is not equal. What does this mean? This means that when we apply this property, that 20 HCF of, where did I keep it? This property that HCF into LCM is equal to the product of the two numbers. That's why I purposely wrote over here, product of two numbers. Because this property is applicable only when we consider two numbers. If we have got more than two numbers and then we find the HCF of those more than two numbers or LCM of more than two numbers, then this property will not be true over there. This property is applicable and holds true only when we have got two numbers, when we are dealing with only two numbers and we are finding the HCF and LCM of two numbers. Only then the product of two numbers will be equal to HCF and LCM of two numbers, product of HCF and LCM of two numbers. So in this way, this topic comes over here. Also, one more topic is there. See now what we have dealt till now. We have understood how to find the HCF and LCM of the two numbers or three numbers, whatever they are. As we have seen, we first find the factors of HCF and LCM. We first find the factors of the numbers and write the factors in the exponent form, and then we find the product of the smallest powers of each common factor, and that gives us the HCF. Then we find the product of the highest power of every factor, that gives us the LCM. This is one topic, finding the HCF and LCM of two numbers or three numbers. We dealt with three numbers also. Fine. Here. At that time also we found the factors, wrote them in exponent form, and then when finding the HCF we found the product of smallest powers of common factors, only common factors, and find them, and that will give us 6. LCM, same way it goes along. Find the highest power of every factor present over there and then find the product of them, and that will give you the LCM. After that we have got one property that if there are two numbers and we find the HCF and LCM of two numbers, then the product of the two numbers will be equal to the product of the HCF of two numbers and LCM of two numbers. Questions can be asked based on this, that find the HCF and LCM of two numbers and then prove that product of two numbers is equal to the product of the HCF of two numbers and LCM of two numbers. Also they can ask a question, they will give you three numbers or four numbers or more numbers, and they will ask you to find the HCF and LCM of the numbers more than two, and then they will ask you to prove that the product of the three numbers is not equal to the HCF of three numbers into LCM of three numbers. This also they can ask you to prove, and that's what we have done now. That we did over here, we had got three numbers and then we found the product of the three numbers. We got them as 21600, and then we found the product of HCF and LCM of two numbers, and it was found to be something else. It was 3600, and then we will bring it to notice that this is not equal, and that's why the rule is not applicable. Another type of questions based on this will be that they will give you the HCF of the two numbers, they will give you the LCM of the two numbers, and they will give you only one number, not two numbers. They will give you only one number. Like supposing HCF and LCM of two numbers are 9 and 459. So dear students, this you should remember always, HCF is always less than the LCM. As I told you, because HCF is a factor. Factor means 9 is going to divide both the numbers. 9 is going to divide both the numbers. And 459 is in the table of both the numbers. It is going to be the multiple of both the numbers. So try to understand, try to sense the difference between the two numbers. Don't stress on highest and the least, though they are very important. But more important are factors and multiples. Factors are the numbers which are going to completely divide. So definitely the number which is completely dividing the other number has to be smaller. Only a smaller number can completely divide any other number. Okay. So HCF and LCM of two numbers are 9 and 459 respectively, of course. If one of the numbers is 27, find the other number. Okay, this will end this topic. Of course, there will be one more topic of HCF and LCM, but that we can do later, or no, I think, no, we'll do later. HCF and LCM of two numbers are 9 and 459 respectively. If one number is 27, find the other number. So actually here we will tell, let the other number be equal to B, or you can take A also, but because my one number is 27. So what I will tell here, HCF of 27 and B is equal to 9. LCM of 27 and B is equal to what? 459. Fine. Sorry. Now what? We know that the two numbers are what? 27 into B is equal to HCF of 27 and B into LCM of 27 and B. Right? This is what the property that we know, that the product of the two numbers is going to be the product of the HCF and LCM of the same two numbers. Remember, two numbers. So what I will get, 27 into B is equal to HCF is what? 9 into 459. So 27 will go on the other side and divide the other side. So what I get over here, 9 ones are 9, 3s are. So this is 9 9s are 18, 9 plus 9 18, 3 1s are 3, 3 5s are 15, 3 3s are 9. So B is equal to 1 5 3. Therefore the other number is 1 5 3. This completes the topic of HCF, not completely the HCF and LCM, but arithmetic, basic arithmetic method, finding the HCF and LCM by basic arithmetic method. The topic gets complete over here. So my dear students, go through this topic. We have understood this topic very nicely. Just see the questions that are given over here, solve them on your own, see how you find this topic. Then afterwards we can go to the next topic, that is, again we have to find HCF, but we have to find HCF by another method, algorithm method, Euclid's algorithm method. and then that topic will take you to a different topic of this real numbers. So that's all for the day, my dear students. Revise this topic. Welcome to the first chapter of maths, real numbers. Hope you find this helpful and practice a lot, my dear students. I love you a lot.